Hey, this is Professor Perez. Today, we're going to continue our work with z-tests for the mean. And of course, we cannot have a class without our student semester, Charlie. You better be ready. Hey, Charlie, you ready to go? Huh? Yeah. All right, you better be. Let's go then. There's our first problem right there. Okay, Charlie. A researcher reports that the average time it takes a student to drive to their community college campus is less than 24 minutes. 30 students are then surveyed, and the time it takes them, in minutes, to drive to the campus is recorded, and there's the data values there. There's 30 of them. Now, at the alpha equals 0.01 level of significance, is there enough evidence to support the researcher's claim? The first thing we're going to do, Charlie, is define what the claim is. What is it, Charlie? It takes a student less than 24 minutes to drive to campus, right? Less than 24 minutes. We're going to assume we have a normal bell-shaped distribution, and we're going to start with step one, define the hypothesis and identify the claim. Okay, remember, for this problem, as we discussed in our previous lectures, we're going to use that 24 for our population mean mu. Okay? Now, we're going to take our 30 data values, right? And we're going to calculate the mean, our sample mean. Now, suppose our sample mean came out to be 24. Would that agree or disagree with the researcher's claim, Charlie? That would disagree. That would disagree because he said it should be less than 24, right? Well, suppose our x bar, our sample mean, came out to be 4. Would that agree or disagree? That would agree. That would agree because that is less than 24. Well, suppose it came out to be 44. Would that agree or disagree? Disagree. Okay, that would disagree also. So obviously there's a division. Disagree, disagree, and agree. So we're going to draw a little line for our division there. Remember, this helps us determine what kind of a hypothesis test we have. Okay, Charlie, so now, do we have a right-tailed, left-tailed, or two-tailed test? Charlie? Left-tailed. We do have a left-tailed test. There it is, okay? Now, here we go. Remember, from our previous lectures, we saw that the alternate always pointed to the tail. That was the kind of little cheat step there. So, since we have a left-tailed test, our alternate hypothesis is what, Charlie? Mu is less than 24. Mu is less than 24. It's pointing to the left. That's right. Okay. Now, the alternate, remember we use that complement technique. If the less than is in the alternate, what's the complement to less than, Charlie? Greater than or equal to. Greater than or equal to. And so our null hypothesis is mu is greater than or equal to 24. There's another little cheat step. And now we have to identify where the claim is. Now, Charlie, is the claim with the tail or is it not in the tail? With the tail. Okay. The claim is in the tail because the tail agrees with the claim, right? And so our claim there is therefore on the alternate hypothesis. All right. That completes step one. Whew. That's always the toughest one. Let's go to step two. Find the critical value, okay? Now remember, everything's going to be translated to z values, okay? The middle region is always the acceptance region. The tails is always the rejection region. Remember, if a test value falls in the acceptance region, you accept H naught. If it falls in the rejection region, you reject H naught. Okay, now the critical value separates the two regions. Don't forget that. Okay, our level of significance is the area of the tail. That's our alpha value. In this case, alpha is 0.01. Now, in order to find that critical value, we've got to find these missing areas here. Now, remember, the area to the right of 0, Charlie, under the normal distribution is what? 0.5. 0.5. Okay, so we have 0.5, 0.01. What's this shaded region right there, Charlie? 0.4900. Because they all have to add up to how much, Charlie? 1. 1. There we go. So that 0.4900 is going to be used to find our z critical value, right? Okay, so we go up here. There's our shaded region, 0.4900. Remember, z table only reads to the right of 0 for this class. And so, look in your table now and look at the area that's closest to 0.4900 and find the z value for that particular area, Charlie. What is it? 2.33? 2.33. That's the closest one. Okay, now, our critical value is to the left of 0. It's a negative value, right? So by symmetry, hey, if the area to the right of 0 is when it's 4.4900, the z value is 2.33. When you go to the left of 0 and the area is 0.4900, obviously that z value should be what, Charlie? Negative 2.33. 2.33 by symmetry. And that is our critical value. So notice that critical value is right there. Okay. That completes step 2. Whew. Let's keep going. Step 3, find the test value. Okay. So remember, middle region, acceptance region, tail, rejection region, right? Always like that. Now, we're going to have to find the sample mean for our 30 data values. Now we're going to calculate it. We need to sum up all those data values and divide by n, which in this case is 30. That's the number of people in our data set. Our sample standard deviation is going to be needed to calculate our z-test value. And here we go. First thing we're going to do, sum up all your data values. You should have gotten what, Charlie? 545? 545, right? Then we're going to sum up the square of our data values. That means you got to square each data value and then add them up. Okay? You don't just square 545. That'll get you a wrong answer. Square each data value, sum them all up, and what do you get, Charlie? 11,635. And don't forget, n is equal to 30. We surveyed 30 people. So now we go ahead and calculate our sample mean, which is summation of x divided by n, which should give you 18.2, and your sample standard deviation should be 7.7. Now notice, from our 30 data values, our sample mean came out to be 18.2. Well, that is less than 24, right? Remember, the researcher reported that the average time it takes students to drive to campus is less than 24. Well, we're getting 18.2. But we have to see if that's a significant enough result to support what the researcher has said. Okay, so here we go. We're going to find our test value. Okay, everything's translated to z-values. Remember, the middle is our acceptance. Tail is a rejection, Charlie. Critical value, negative 2.33. Our sample mean is 18.2. Our sample standard deviation is 7.7. Our population mean, mu, is 24, assumed to be 24 for this problem. And there's our z formula for translating that x bar value, our sample mean value, to a z. We're going to use one of these formulas. I'll use the first one. Plug in our values. X bar 18.2, our mu, population mean, 24, sample standard deviation, 7.7, and multiply by the square root of 30. We get z equals negative 4.13, and that is our z-test value. Now notice here, our z-test value is falling to the left of our critical value, which means it's falling in the tail, which means it's falling in the rejection region. That means our decision should be to reject H naught, of course. Okay, now let's review here. Remember, our sample mean was 18.2. When translated to a z-value, it comes out to be negative 4.13, which puts us in the rejection region, right? And so let's go to step 4, which is to make our decision. Remember, here we go again. Acceptance region, rejection region, Charlie, critical value, and there's our test value falling in the rejection region in our tail. And therefore, we reject the null hypothesis. That is our decision. Okay, one more step, which is our summary now. Now, there is our step 1, our stated hypothesis with the claim identified to be on the alternate hypothesis. Our test value, negative 4.13, is significantly different, significantly lower from the mean. So we do have a significant result. In this case, there is significant evidence to reject the null hypothesis and therefore support the claim. Remember, we found the rejection region, so we're going to reject H naught. So here's our final summary here. There is significant evidence to support the researcher's claim that the average time for a student to drive to the community college campus is less than 24 minutes. And that's it. Remember, if you have any questions, come to my office hours, go see your facilitator or your parents, and get it all straightened out. We'll come back and do some more problems soon. Oh, what fun. See you all soon.